So I'm trying to think about, like, I had problems with the last, like, 3 trying to figure out the radius, and I think for the first one, I
Hi, Christine.
Hi.
think I kind of know, but
Hi, Josh. Okay, back to you, Maggie.
okay. So for 20 on 6.5,
Okay.
I was looking at, like, because I drew the graphs out for all of them already, but like I was having like a hard time finding the radius with the like r squared minus little r squared. So for 20, I was having a hard time with, like, so the bigger radius is taken from, you know, the function on this one to the axis, but because it's like stopping at y equals 1, I was wondering why it's not like x to the third minus 4 as opposed to x to the third minus 3, which is what it has on like the solution.
I think it's probably x to the third minus -3, I'm guessing. So it ends up being x to the third plus 3, right? Okay, and so I'm going to go right on the board behind me. Do you think you'll be able to see that?
Let me click.
So we have y equals x to the third, and then can you help? What were the other equations? Y equals x to the third, y equals 1, x equals 2.
About the y -3.
X equals 2. So I guess you're going here. And so is it this region right here that, oh no. Party every social gathering. X cubed, y equals 1, x equals 2, about y equals -3. Okay, so is it this region right here then that we're looking at? And then it's rotating about -3, which would be down here?
I'm not really sure.
Okay, let me see what I'm looking at.
Like you're having so much more fun than everybody else.
Y equals 1. Oh no, it's above the y equals 1 and the x equals 2. Oh, right. Okay, sorry. Okay.
Yeah, that was another thing that was kind of hard to figure out, was like what the region we were trying to find was.
Yeah, figuring out the original region is a really important part that is sometimes a little bit tricky. Okay, so we have y equals 1. We have x equals 2, which is going to be somewhere over here then. And so that it ends up being when the y cubed, I went too far, but it's that part up there because that's the part that's bounded by the x cubed graph, by the y equals 1 graph, and by the x equals 2 graph. And so that's your region that's gonna get revolved. And then that's getting revolved around this. So I'm not gonna be able to draw it, the other part of it the way I have this here. The 3-dimensional thing anyway. I won't be able to draw the 3-dimensional thing, but I can show you. So the outer radius is going to go from the axis that you're rotating around. So this y equals -3, right? This is my y equals -3. And so it goes from there to the outside edge. And so that's the furthest away point in the shaded region. So that's going to be my big radius. And so that's the x cubed minus -3 because it's the high y minus the low y. So does that make sense for the big radius? Y, that would be x cubed minus -3 because the y high would be x cubed and the y low would be the y equals -3.
Yeah, because I got it for the little radius. It was more obvious than the other one, but I understand where that is.
So the little radius for those other people that are watching goes from the axis you're rotating around to the closer edge of the shaded region there. And so that's the y equals 1 minus the y equals -3, which is a little bit more clearly the 1 plus the 3 that's down here, making that the 4. Okay.
So for 23, this one was trickier because it was like, it starts off where you feel like you should be doing it in terms of X, and then it becomes clear that you should be doing it in terms of Y. But
what was it that made you realize that it should be a dy problem?
Because it's like the way that it's positioned on the graph, the radius is going like the sections are in that direction.
Right. Another way a lot of people tend to think about that is because it is revolving about an axis that's parallel to the y-axis, that makes it like a dy problem.
Mm-hmm.
So that's just another way to think about that, because that's another really important first step when you're doing these.
But it's like the axis that it's rotating around is x equals 2.
Mm-hmm.
So I was having a hard time like figuring out how to take the function, which is like big R, little r, and what that would look like.
Mm-hmm. So this one I kind of drew up ahead of time, and you can tell me if this works for you, if you can see this or not, but I'll try to hold it in front of my camera because like I said, I tried to kind of start to draw that one at least.
Mm-hmm.
And this is really hard for me to do like this because I can't see it when I'm showing it to you like this, but the big radius then is I'm gonna take a quick peek, goes from the axis that you're rotating around to the furthest away edge of the shaded region. And so the x high ends up being the x equals 2, and then the x low ends up being that curve, which was defined originally as y equals x to the 3rd. But because you decided this was going to be a dy problem, you need to rewrite that y equals x to the 3rd equation.
Mm-hmm.
That is a function of y. So solve it for x. So I did that up there where you just cube root both sides so that x is the cube root of y. So then that big R ends up being 2 minus that cube root of y.
So I'm trying to look at this because you're taking it from like kind of like that direction.
Okay, I can't see that. Let me change my view so that I can see your picture bigger. From what direction?
Because it's like, if you're looking at it like this, kind of, like I'm having a hard time wrapping my head around that.
Which part of it are you having a hard time? Like the high X and the low X, that idea?
Yeah, in terms for this problem specifically, I'm not sure like how I'm supposed to be looking at it.
Okay, so the high Y and the high low is always more obvious because you have positive Y values up and negative Y values down, right? And so that's how you know that that's the higher Y value is the up and the lower Y value is the down. In terms of the x-axis, if you think about the positive X values being to the right and the negative X values being to the left, right? Did I get my left and right correct?
Yeah.
The high X is always going to be the X on the right, and the low X will always be the X on the left, because again, the positive X's are to the right and the negative X's are to the left. And I think this book actually will, instead of saying a high X and a low X the way I described it, they actually say X right and X left. I believe that's what I remembered seeing. But I don't like that because I think it's hard to remember. I think if it makes sense to you which one is the high X end and which one is the low X end, it makes it easier to remember.
So the little r would be 2 minus 1 then?
Yes.
Okay. that makes more sense. Yeah. Yeah, and I think the last one
Uh-oh.
will be
I didn't hear what you just asked because you stalled somehow.
I think the last one will be easier to figure out now that I kind of have a better idea of what's.
I
The
need help.
one thing I will say about the last one though, Christine, did you have a question
Mhm.
first?
I need help with it. I
The
don't know
last
how to
one?
find like the areas.
So the last one has, you have to separate it into two different integrals. So I kind of started to draw that up. Does that drawing there make sense?
It kind of looks
Yeah,
like mine, but neater.
Yeah.
So one thing to think about, let's see, I'm going to draw a couple of cross sections on there. I'm going to take this down for just a second, but I want you guys to think about how the top part of that is kind of like a cylinder with a cone removed, and the bottom part is a cylinder with a cylinder removed. So it's like two different shapes. So I'm just going to draw something real quick on there. Gosh, I don't know if this is going to make this more clear or more confusing, but I will try. Yeah, I don't think it's gonna make it anymore. But
Just having to rotate it about the x equals 1 was really hard.
Yeah.
Oh my gosh. Sorry. Oh my gosh.
Okay, yeah, I don't think that helped at all. But at any rate, so the top half of this here is a cylinder with a cone taken out of it. And I kind of scribbled on it. And so I think that almost made it harder to see. So you have to split this up into two different regions. I think that, I don't know if the book did it like this or not, but to me, when I look at this, I'm going to have to do one integral where my big R down here goes from 4 to 1. That would be my big R down there. And then the little r down here is going to go from 2 to 1. But then up here, my big R is still 4 to 1, but now my little r is from the line here to the axis. And so it's at the point where it's at the point where that line y equals x hits the line x equals 2. So right there, I don't know if you guys can see that. That point right there is where the shape changes. So the bottom below that point is a cylinder with a cylinder removed. And then the top above that point is a cylinder with a cone removed from it. So you have to set up two different integrals. So I have to go soon because I have a Math 3 Zoom scheduled at 11. But I'll leave you guys with the idea that, let's see, this is a dy problem, right? So I'm going to have two different integrals. Can you guys see what I'm writing? Where I go from a y value of 0 to a y value of 2 for this bottom part. And then another integral that goes from 2 up to that top point there, which I think is at 4, right? And so I have a different big R and little r for each of those pieces because they are different shapes starting at that y equals 2 value there. Okay. So if you guys would like to, we can do another one of these this afternoon. I don't have anything else going on this afternoon. It's just from 11 to 11:30. I have a Math 3 meeting that I want to go get ready for. So.
Okay. Yes.
Okay.
Thank you. Try and figure that out.
Okay, sounds good. So Christine, maybe we can check back later, okay?
Well, I just needed, because I found the 8 pi one, so I found, I think, the 2 to 4 one, but I don't know the 0 to 2 one. I found one of them.
I think you found the bottom one.
I
Because I think that
don't
one's
really
going to
know.
be a little bit more straightforward, but I'm not positive.
because I haven't worked out the whole thing myself for sure. But
Because
anyway.
I know one of this is gonna have to involve the X and the 1.
How about you send me a picture and I'll tell you how I think you're doing, and I can finish this later and send you a picture of it if you want.
Okay.
Sound good?
Thank you.
You're welcome. I
Okay.
will chat with you guys later. Welcome. Bye-bye.
Bye.